Welcome back, teachers and administrators and STEM leaders. It's Friday. Thank you all for showing up this week for Phenomena from the Field. We're very excited to share this all with you guys. Today, we have Dr. Teresa Wriston here to talk about our drying deserts. And so we are going to start with Teresa telling us about your science story, where it all began for you and the moment you knew that you were going to be a scientist.
Well, it's funny because I was raised on a ranch in Western Colorado, and so I was always really curious about everything going on around me. We didn't have a television, so I was outside all the time and really learned to observe animals and nature. And we had this little gentle stream that went through the ranch, and every year, usually July 4th, because we would have to choose between going to the fireworks and watching the massive flood, this huge torrent of water that was 3 stories high would, just gouge through the ranch and carry all these huge boulders and leave them distributed. So that really made me think, wow, water can carry boulders, and how does that happen? And so there's all kinds of interesting weather phenomena that were always going it didn't rain where we were, right? And then here comes this big torrent of water. And so really think about weather. And then, we would have freezes, really late freezes during lambing, or our crops would be destroyed by drought. And I think that really made me aware of how the environment really impacts food production, where our food comes from, and our lives, much more so than someone that was living in town. But honestly, I didn't think I would become a scientist until I found a job doing it. So I went as a first-generation student. I was basically getting a degree so that I could be a supervisor or get paid more. I had no conception that a little poor ranch girl could become a scientist. And then I got my first job doing archaeology. And once it became a viable career option that I could pay my rent with, then I was like, okay, I'm going to pursue this. So it was a process.
Can you tell everyone what you do at DRI and how long you've been there?
I'm a geoarchaeologist, or technically I'm an assistant research professor. So at DRI, we go out and look for grants and contracts. And what's great about archaeology is it's part of the environmental regulations. And so whenever development happens that requires a federal permit, or on federal lands, which is 80% of Nevada, are federally controlled, they are required to look at archaeology and consider it before whatever is being proposed happens, whether it be a highway or a mining clear cut. So there's actually a lot of archaeology that is required as part of those environmental regulations. That doesn't mean it's going to stop the project, but they do have to consider it. And usually the only time we go through and excavate is whenever we're going ahead of a project and trying to get as much information as we can and save that information before the site is completely destroyed. So, and I'm a geoarchaeologist, so I do a lot of paleoenvironmental reconstructions as well.
Awesome. So today, you're meeting with all of these teachers to talk a little bit about scientific phenomena that can be used to develop inquiry-based skills in the classroom. Can you tell us one phenomena that you study in your work as a scientist?
So the one I came up with was essentially people's day-to-day lives and decisions reflects the natural environment that they live in. So fundamentally, we all need water, food, and shelter, and the availability of these fundamentals varies regionally, topographically, and seasonally, and they've also changed through time, right? So 15,000 years ago, there was a different suite of these fundamental needs available to people at different locations. So that's changed through time. You could, if you think about, in Fallon, for instance, you would be underwater 15,000 years ago, right? So things have changed a lot since people first arrived.
Can you tell us why this phenomena is a good example of the skills needed to figure it out? And why should kids care or be motivated about this phenomena?
Well, I think this pandemic has really revealed sort of the shortcomings in our food supply. So I think that has maybe brought to head this in many of our minds. So everyone should think about, what would I eat or drink if the grocery store wasn't open or I had no money? And I overheard a coworker say, oh, well, around here, we would be screwed. There's nothing to eat or drink. But that's not true. Native Americans have been living in the Great Basin for the past 15,000 years very successfully. Now, given our population, that might be a problem. But there's actually plenty of resources around us. We just don't know what they are.
Can you talk a little bit about the pattern that you study related to this phenomena?
Again, the pattern I'm most interested in is how people have adapted to environmental challenges throughout time. And, water and food supplies there are shortcomings. So even though they're available, they're not always readily available. You really have to have knowledge base and the technology in order to find those resources. So I really want to look at both how they adapted in the short term and the long term. And I actually have a slide to show how much change has occurred. So we'll see if I can manage that. Oh, there we go. So over to this left here, here's Reno and Las Vegas, and you can see this is an aerial shot or a satellite image of the Great Basin, which is the white line here. Now, to give you some perspective, this is Salt Lake, and this is Pyramid Lake. Lake Tahoe is here. So the Salt Lake and Pyramid Lake are sort of remnants of what once was a huge system of lakes. Whenever people first arrived, this is more what it looked like over here on the right. So it was really a land full of lakes, and there's a bunch of resources associated with marshes and wetlands and lakes. And if you think about it, these are freshwater lakes at that time. So your most fundamental resource, water, would have been much more readily available then. And then around 8,000 years ago, it became near modern. So that's pretty rapid drying and required a lot of change pretty quickly. So it was once filled with large lakes that had lots of animals and plants. And if you go across any playa, so if you go on I-80, you go through a series of these playas. And if you look up on the mountains, you can see the steps where the old lake shorelines were. And so where you're going to find archaeology is going to change. Where you're going to find food and water is going to change through that time.
What is it about this phenomena that provides investigable questions? And that's something that students can answer through systematic observations and interpretations of their data.
Mm-hmm. Well, again, we can only live a few days without water, right? And we can live maybe a week or two without food. But Western deserts are quite challenging. So I think that first of all, I think the students should think about where they are in the environment, just like I hope that you guys all did when you started thinking about, okay, where's my nearest water source? That's probably not something you'd really thought about in a while. But if you have your students start thinking about where they are in the environment, what sources of water are they, can they drink them, and why? And what sources of food are there? So both plants and animals. And what would they have to do to collect that food and process it so they could actually safely eat it? Again, how much energy would all that take? So even thinking about calories, like calories in versus calories out. So how much effort does it take? Do you have to climb a mountain? Because that's a lot more energy than if something is 10 feet away. These questions are easily investigated by a range of grade levels, and you can begin with just plant and animal identification. What types of plants and animals can you identify within your environment, within your yard, within, especially with online learning right now? Can they go around and identify weeds that are growing in their yards? Ornamental plants, it's probably not quite as useful. But even in their block, like, can they go around and find food resources? And first the first key to that is being able to identify these animals and plants. So there's lots of different questions and investable questions, I think, for a range of different grades. Poisons, that's something to emphasize. Don't put every plant in your mouth, right? So things like death camas and camas, one's blue and one's white, and I always have to look it up because I don't want to eat the death camas. It will kill you. But otherwise, it looks exactly the same. And so, of course, you want to collect that during the blooming season because that's the best difference indicator, is the color of the flower. So animal behavior. So, you can draw on hunting. How would you do that? And not just deer and antelope, but ducks and bunnies. Bunnies, those were actually one of the primary food resources for Native Americans in the Great Basin. And also think about, especially if you're up north, how are you going to find shelter in the winter? Clothes. Rabbit fur was extremely important for winter clothing. So those kinds of things. Soil types. So, some of the soils are too saline now. As the lakes were drying, the heavy salts collected in the bottoms of the valleys, and those soils are basically sterile. And so there's just such a range of questions that cover geography and topography and biology that come back to human problems. We really are part of our natural environments. And I know this is actually, I had a visitor to a lab I was running at the time, and he thought he could live off ducks alone. So he was just going to hunt ducks with his dad. And I was like, well, what if there's no shot available? What if you don't have a shotgun? And how are you going to kill the ducks? And are they available year round? And so very quickly through this questioning, you can make them realize that maybe they need a broadening of their diet. You can't live off ducks alone, right? So, and not only that, but how many people are in your family? How much energy do you require? How much do you have to find to eat to sustain yourself? And how much do you need to drink? And how big is your family? So all of these things, also moving. So that's one of the best ways to adapt to a changing environment, is to move to somewhere better, which is great until other people become involved. Right? So what happens if resources you're counting on that were there last year, you get there and somebody else has already eaten them, or somebody else is already there? So you can think about territory and how that affects how broad of a range you have to forage to find what you need to eat and drink on a daily, weekly, and annual basis, and how population pressures really come into play. So like I said, Native Americans were very successful to their adaptations in living in the Great Basin, throughout the Great Basin, until population, we can't just go back to that now and maintain our current population. So that's something that students can think about. Seasonality is really important. And, that really affects, do you need to store food to make it through the winter? Can you move down south, or, can you move to where the food is available currently? And is that most effective? Thinking about how stationary we are, that's actually unusual throughout time. If we look through human history, being stationary is not a common phenomenon until the last 10,000 years, until agriculture.
Changed it all.
Yes. Oh, and as an archaeologist, the way I approach this problem begins with background research. So research is fundamental. I got to know what we currently know about the past environmental conditions within the project area. And then I go out and look for evidence to help fill in the environmental gaps, but also for people. And a lot of times the evidence that people leave will help us also learn what the environment was doing. So people were living along shorelines of marshes and lakes. And sometimes we can just use spatial analysis, right? And look at where we see the distribution of archaeological sites to help us figure out what the food and water distribution was. But we also look for datable food remains in ancient hearths. So if we find a charcoal stain or fire-cracked rock, which has been exposed to very high temperatures, we can actually get radiocarbon ages, and we can look for food debris from those ancient hearths. We can look at past plant communities, water levels, and water quality from sediment cores. So we can take a core that's just about this diameter and get a lot of information through time. And we can even look at pack rat middens. So pack rats are true to their name, and they collect everything within a 100-meter area of their den. So that gives us a great sample of what was within 300 feet. And because we can directly date, say, a pine cone or a pine nut, we know pine was within 300 feet of that den at that time, and so we can actually use that. And the best pack rat middens are well preserved. They're in dry areas, and what they do is they urinate over their nest. So it's amber rat is what it's called. And the settlers actually thought they could eat it, and they got very sick. So it's just urine, but it really forms this little time capsule of everything that was within that area. And the oldest ones in the Great Basin are over 40,000 years old.
Who knew that pack rats would be helpful?
Oh, and then also, I forgot, there's also human feces. So that's the best direct evidence, right? You know exactly what those people ate because you found their poop. And so if you find that usually in dry caves, then there's no question that people ingested that plant or animal material. A lot of times you'll find rat skeletons and stuff complete. So there wasn't much chewing or there was some challenges going in and out, I think, in some instances. So there's some really interesting things that you do find. Maybe there was a dare involved, probably a teenage boy. But if they were grinding seeds, they leave large grinding stones. So most of what we find as archaeologists is grinding materials or lithics. So evidence of rock artifacts, because basketry and more wood artifacts, perishables often deteriorate in open settings. So unless we have a nice dry cave, we don't usually get preservation of that. And then also I wanted to show something. So what people would commonly call arrowheads, we call projectile points. And that's because the technology changes through time depending on what people were hunting. So if, let me see if I can get this shared. So if we look over here to the left, this is a spear point. So the earliest peoples in the Americas, probably around 15,000 years ago, this is a spear point, the thrusting spear. So what they were doing is essentially running up to mammoth and bison and really large game, or even fishing with these thrusting spears. So we have the earliest technology are these very large projectile points, right? Those are not arrowheads. They are projectiles, but they're thrown on a spear. In around 8,000 years ago, the atlatls became dominant throughout the world. And these have really effective leverage. And You don't have to be big or even strong to really get some good leverage on these atlatls. And this is really good for taking down elk. You can take down mammoth if they were still around 8,000 years ago with these atlatls. So projectile points went from very large to sort of medium size. And then later in time, you have the bow and arrow. So that's when you start getting the smaller projectile points or the arrowheads. And that isn't until about 1,600 years ago. And these are most effective for taking down small game like deer, really agile game. So things that are flighty. So pronghorn, deer, bunnies, small game, where the atlatl is good for elk or things that aren't going to run away really quickly. They don't have a really strong prey drive. And here is some of the oldest projectile point types in the Great Basin, just a few examples of what I found down in Lincoln County for those Lincoln County folks. So these are traditionally called clovas. This is just a base, and this has a flute. So it's a very distinctive technology, and these would have been much longer. And this is a crescent, very famous Great Basin type. And there's lots of arguments. We like to argue over what these were used for, but I think they were basically sort of the Swiss Army knife of the Great Basin. So used for a lot of variety of things. So we can look at the technology, the lithic artifacts, and sort of derive what people were hunting, right? And so that's often what is preserved. And we also get some hooks and that kind of thing that indicate fishing. So I think that's it. That's all my notes that I had for that question.
Awesome. In the course of your career, I'm sure you've generated many research questions, and we heard a whole bunch of them. Can you tell teachers and tell us what makes a good question, and then what are some common errors in research questions?
So I think that for me, it's very obvious when someone is authentically curious about a question. And I think the biggest mistake is to come up with a question to satisfy your teacher or your boss and just sort of go through this rote process. It's very obvious. And it's obvious whenever you're actually reviewing articles where people are coming up with those kinds of research questions. Because we're all really good scientists when we're 3 years old, right? We're making hypotheses. We are like, okay, learning how to walk and talk and dance, and that stoves are hot sometimes. And those are all hypothesis building, testing, and basic science. And I think that a lot of kids get scared from science because of the rigor involved. But I think if we can incite that curiosity and tell them they all start as good scientists, that helps a lot. So first, I think the best questions seem very simple at their face until you start making a list of all the things you need to know to answer that question. And through that process, that's how I hone my questions. So that's how you find out what you're really interested in that the fundamental of that question and how to come at it at an angle that hasn't been explored yet. So for us, that novelty is important to get funding. They're not going to fund a question that has been answered already. And I have here the most common error is essentially just trying to come up with a research question to satisfy somebody else, because that's very transparent. You have to be genuinely curious about it. Otherwise, people will know. And it really takes a lot of hard thought. And I think that that's the one thing I see whenever I do teach that's often missing is that practice of hard thought. And I think that, I think that fostering that in students, that sort of going through that frustration of really doing the background research and trying to think of different angles, that takes a lot of energy and a lot of thought. And that's what comes up with the best research questions that are both novel and interesting. Oh, and of course they have to be testable and, can we actually find evidence to refute them or support them? So that's the basics.
Great. And a big part of your job when mentoring future scientists is teaching people how to think. What mentorship advice do you have to help students move from memorizing to asking questions to figure it out?
So I think that the best budding scientists are going to be the most challenging students. And that's because they constantly ask why. And they always, they start out when they're 3 and they continue. Why? And so just telling them to lay a brick in this scientific foundation of knowledge that they're going to need isn't going to be effective. I think that you have to show them why they're laying the bricks. You have to show them the engineering plans of the building that they're building, the foundation that they're building. And for science, that's a research design. So I think that the best way to really tease out science is to think about research designs. Explain to them why they need to know this information, why they need to lay that brick and build that foundation. And that's really tough. And I don't envy the teachers' jobs very well, because until you really start seeing why something is important, it's tough to really remember that. I do a lot of isotope studies, and thinking back in high school, I had no idea the cool kinds of questions that you could answer with isotopes. And I think that you're striving here with this phenomena to really sort of bridge that gap. So I think this is a good way to do it. But in archaeology, and this is, it fits with my curiosity of why, is it's a systems approach. So you have to sort of understand the entire system in order to understand something. And from going from large scale to small scale, both geographically and temporally. So through time, it really helps you start critiquing the data and critiquing your research questions and what you know and what you don't. And I think that process of always questioning, always trying to help them answer the why rather than stifle it, because I see a lot when the most curious students are always asking why, and that can be trying, and they're often stifled because someone doesn't know the answer. And if you can turn that into, well, let's find out. And what I did, had the benefit of being in college. I would give them extra credit. Like, you go figure it out and come back and tell me. And then you'll get extra credit, and then we can all learn from it. But, in grade school, I'm not sure how you do that. And it's funny because my dad is always quizzing me on some obscure Egyptology reference that he learned on the History Channel. And I'm not an Egyptian archaeologist. I don't study Egypt archaeology. And I always tell him, I'm like, college didn't teach me everything. What it did is it taught me how to find out the answer. And I think that that's the thing to really drive home with while they're building that scientific foundation, is like, this is how you're going to know how to figure out the answer to the questions you want to ask, is building this foundation. Oh, and then also lastly, I think that we have to fight the urge to immediately step in whenever we see a student or an employee struggling, and to know when to step in and provide some guidance and when to step back and let people struggle and find that answer for themselves, because they're going to value it and remember it a lot more. I think that's the hardest thing about being a mentor.
Great. Thanks, Teresa. So next is the opportunity for the science teachers and elementary school teachers and middle school teachers to ask questions. So if you have a question for Teresa, go ahead to your chat box and you can type it in, and Megan will take over calling on you. Just remember to unmute and start your video so you can ask your question.
So I have a question that is going to be a segue to the first teacher question. Teresa, can you explain first what makes a geoarchaeologist different, or what makes your career different from a traditional archaeologist or a conventional archaeologist?
Sure. A geoarchaeologist essentially uses geologic methods to answer archaeological questions. So I was an archaeologist first, and then I became very fascinated with landscape developments and processes and how water impacted the environment and the land, whether sites were preserved or destroyed. So I am very focused on context. So where is an artifact? Is it in the place that people dropped it, or has it moved? And is it buried? You know, so I do a lot of predictive modeling of where sites will actually be preserved under the surface, and where they're going to be exposed, where they've eroded off, where you're not going to find any because of natural processes. And so that's really the difference. Is I'm really using a lot of geology in addition to archaeology.
Cool. So Anna asks, what is the most interesting geoarchaeological find that you've made?
You know, I get this question a lot, and it really, there's a lot of interesting things. And I won't actually go into some of the stuff that I really like, because, you know, so you start talking about dirt and people's eyes start glazing over. But some of the most fascinating things to me are how clever people have always been, right? And how good they are at making artifacts, you know, out of stone. Like the level of artistic expression, even from a functional artifact from 10,000 years ago, is really great. And one of my favorites was, one of my earliest finds was a bracelet of shell from the ocean, and I was down in Arizona, and it had been etched with acid into a design, you know, and traded long distances 2,000 years ago. Same thing, we have Olivella shell beads in the Great Basin that come from the coast. People are trading and moving, and I think that people constantly underestimate what people of the past are capable of. So they were moving a lot. They were well informed as to, you know, finding other people and figuring it out. And yeah, I think every artifact is interesting in its own regard, and you know, anything over 50 years is an artifact. That's not people, but it's the realm of archaeology. So, you know, oxen shoes, they used to shoe their oxens. Those are some of my favorite historic finds, is on old trail systems. And you'll see trails that have the wagon wheels like rutted into bedrock. So those things are all cool, you know. And I did my doctoral work in Southern Africa. So finding buried rock art that we could date, that's always really exciting. Is being able to date rock art is always a challenge.
Well, I'm going to ask you to hold that thought, because there's a question. Actually, Janie, why don't you hop on right now and ask your question related to rock art?
Here we go. Okay, here I am. I don't know where I wrote that, but anyway, I'll just wing it. I guess I was asking about petroglyphs, particularly in Nevada. How do you know, which tribe or which type of, Native American, and how do you understand them? How do you know what it means? How do you know what they're trying to convey? Is it art? Is it communication? Is it a road? Is it a road sign?
Well, as far as age goes, we can look at the patination. So for petroglyphs are the packed ones, right? And pictographs are the painted rock art. And so there's actually been a recent analysis, I think it was in 2013 up at Pyramid Lake, at some of those petroglyphs. The lake actually came back up and buried the petroglyphs after they were done. And then when the lake receded, it left a rind of calcium carbonate that was actually datable. So they know that that rock art is 13,000 years old, and that's abstract curvilinear, so that's a style. So you can look at the style features. And there's some similarity of similar motifs, similar designs that you can sort of trace in different regions through time. And then if you can couple that with these instances where we have datable associations. So in that case, it was calcium carbonate that coated the petroglyph. In other cases, you can look at relative dating of the degree of patination. So that iron rind or that desert varnish that starts to come back over some of those petroglyphs, like out by near Hidden Cave. You know, you can see the different varnishes of the most recent petroglyphs are going to look much fresher than the oldest ones. So there's that relative dating technique. And another great thing we have in the Great Basin is tephras, so volcanic tephras. So like, for instance, Mount Mazama blew its top and created Crater Lake 7,620 years ago. Well, in some cases up in the northern Great Basin, that blanket of tephra or ash covered some of the rock art. So we know that that rock art style is older than 7,600 years ago. The Fremont, when they came in, especially down in southern Nevada, you know, around 1,600 years ago, 1,800 years ago, it depends on the research or exactly what area you're in. And they have a very distinctive style that you can trace from Utah. And so that, in association with their other kinds of, they have a really distinctive suite of artifact types. You can date that rock art style based on that association. So usually it's by association. It's not directly dating the artifacts. Mm-hmm.
Really cool. Sonia, do you want to jump on? You have a great question.
Oh, I just wanted to know if you had any suggestions on early life in the Great Basin, like survival, specifically if you had any on southern Nevada, Las Vegas area.
Well, I actually have been working down in Coal Valley, which is in the Basin and Range National Monument. And so we just got a new radiocarbon age on the age of that lake. It was here 16,000 years ago. So when people first arrived, they probably still had wetlands in a lot of areas around there. And you think about Las Vegas Spring, and there's been mammoth found in a lot of those spring areas. Springs are really important in the Las Vegas area, and well, continue to be, right? And that's the first places that, if you look at historic settlement patterns, you can probably imagine that they're almost always associated with springs. And that's a good way to trace it. And it began pretty early in Las Vegas. So that vegetation shift and the drying pattern down there happened a little earlier than it did to the north, right? Because of the jet stream patterns. But also the rock type is different. So you have a lot of sedimentary rock down there. So you actually have springs that are fed from Utah. So you have a huge catchment area that is traveling through those sedimentary basins and over into Death Valley. So there's a whole series of springs and fracture patterns in there that were always utilized. So people have been there since the beginning, and they've used that area even as it's changed. So the vegetation changed. That used to be much more like, if you went north maybe 150 miles, that's about what Vegas used to look like. And then there's the Colorado River right there. So the Colorado River corridor is really important, always, because it's a consistent, reliable water source, and it's a natural travel corridor. So people were there, and they were doing a lot of the same things. You know, they thought that they found evidence of them utilizing sloth and mammoth very early on, like at Gypsum Cave. That's been debunked. The sloth are actually way older than the artifacts, and that has to do with context, right? Context is everything. So we still are looking for the mammoth with a Clovis point through its pelvis. Haven't found it yet, but we're still looking.
So knowledgeable. We've just been talking about past adaptations. This is a question from one of the teachers when they registered. Forecast for us what life may be like in 20 to 50 years in the Great Basin and the Mojave, and then talk about what adaptations we might need contemporarily.
What was the last part of that question?
Talk about what adaptations we might need contemporarily, how we can learn from them.
Well, I think I'm going to start there. So let's put it this way. In this pandemic, I wasn't surprised, because if you look back through history, and that's what archaeology is great at, is giving you a perspective of cycles that have happened before, and pandemics have happened, and civilizations have fallen. I mean, Romans are probably the most similar to us if you look in the past, and they fell, right? Because they got too complex, too separated from their food supply, would be my argument. And so I think that I expanded my garden this year. It's 4 times bigger. I do think that we need to get away from yards rather than edible gardens. That's actually tied to essentially the Victorian era of proving how wealthy you are, is you didn't need to, you could water some senseless vegetation rather than food. And so I think we need to get away from that. I think homeowners associations need to change, and we need to get back to gardening and getting a little bit closer to our food supply, knowing what is available in your area, knowing what water you could drink. When I was growing up, we used to laugh at people buying water at the convenience store, because right behind the convenience store was the spring that we filled all of our water jugs with. So knowing your environment, I think, is really important. And I think that's something that we can all do to start with, is just knowing, like, maybe we shouldn't weed that weed. You know, dandelions are edible and a good food source. So those are little things that we can do. And it's a lot better for our environment as well, rather than watering lawns and things. And so the climate models, especially for like the Phoenix area, look really terrible. And so I read one that essentially said that in 50 years, Phoenix would be uninhabitable. So Vegas there is a little difference, because you have the El Nino and the Pacific climate that affects all of that. But with the change that we are expecting, the climate volatility, we expect more droughts. And this has been the hottest year on record so far ever recorded. And so things are definitely changing. And microenvironments are changing. So I think that we all need to be aware of that and focus our resources more carefully. So really conserving water, conserving groundwater, and making sure it's not contaminated. I think water is number one, and I think hopefully that has come across. We cannot live without water for more than a couple days. We should be protecting that resource at all costs. And I think that that's really what my recommendations come down. All the models, there's plenty available online, look at different climate model simulations for 50 years out. I haven't done the ones for Vegas in particular, but it's drying. Lots of drought, lots of volatility, and that's what makes agriculture hard.
Big sigh, big inhale.
Population density, yeah, I think we have too many people and not enough water.
Yeah. So Chrissy's next question touches on something that you did mention. Chrissy, do you want to come on and ask your question? And Teresa can go deeper into that topic.
Yep, she just led into it. We see evidence around the world of ancient civilizations collapsing due to environmental factors. Do you see a future when some of our larger cities in the Southwest, Phoenix and Las Vegas and others, may have to be abandoned due to limited resources?
Absolutely. I mean, I think it's not only that, but the coastal areas. So most of the population lives in the coast. So Miami is forecasted to be underwater within 50 to 100 years. And it's actually happening faster than we thought this would occur. And the problem is their fresh water is also going to be contaminated. So even if they're still above water, their freshwater resources are going to be contaminated by salt water. So those people are going to have to go somewhere. And they are going to move further inland at higher, drier locations. And, you know, deserts can't support high population densities for a sustainable amount of time, particularly during droughts, right? So Colorado River is the source for both Phoenix and Las Vegas. You know, there's been tremendous subsidence around Las Vegas. I don't know if you guys have noticed the big cracks. If you go to Google Earth and look at the cracks, particularly on the north side of Las Vegas Valley, those are subsidence features. And just in the last 30 years, it varies, between 10 to 30 feet, the ground has dropped because the groundwater has been withdrawn. So even with the Colorado River close by, water is a real challenge. And, you know, the Colorado River is pretty much drained by the time it's supposed to empty into Baja area, and it's pretty much a trickle now. So yeah, it's absolutely going to change things a lot. And I think it's going to happen a lot faster than we hope. So it's good to prepare people though, you know, and I think that if we, like I was shocked when Katrina happened, because I was taught, you know, New Orleans is on this geomorphically dangerous delta, and it needs to build sediment. And by people diverting the water in certain ways, basically New Orleans is now below where it should be. And that river wants to deposit sediment there. So learning these processes, I think, is much better than having our head in the sand. And that way we can make informed decisions and prepare.
Awesome. I'm going to ask another question from the list of questions that teachers asked when they registered. And I think it would be interesting, Teresa, for you to interpret this question within the lens of a career and encouraging, you know, science career, either career choice or STEM identities, like students seeing themselves as a scientist. What message or action should teachers bring back to their students and or school communities after listening to this presentation? Or basically, what kind of takeaway would you want to send teachers away with about STEM career choice?
Well, I think STEM overall, I think that it's a way of knowing about the world. And I think that being curious with the world around you is really important to help solve some of these very problems that we're talking about. And as an archaeologist, I have a bias in that if you look at the past, that's your best forecaster for what's going to happen in the future. So if we look at past variability and what has happened, then we sort of see the parameters of what could happen in the future. And that's our best forecast. So for instance, if you are on a dry playa, you know that used to be a lake. There was standing water. That's what formed that dry playa. Don't build a house there because it's very likely that it's going to have a lake in it again. So those cycles, I'm terrible to go house shopping with. Big boulders in your yard. Where did those boulders come from? Were they trucked in? Oh, you're probably fine. But if they came from the mountain above you, guess what? The likelihood of another big boulder coming down and crashing you into your house is very high. Much higher than if there's no big boulders in your yard. So look at what's around you, and understanding the landscape around you and how it's formed is going to help you forecast what will happen to it in the future.
Awesome. I would want you to come house shopping with me. I don't know. I think those are some really, really helpful tips.
Yeah, it's true. I have some friends that are just like, I was like, you bought there? And I sent them the like 1997 flood aerial photo. Like, there's your house.
Yeah. This is another question from the teacher registrants, which is really close to my heart as a citizen science advocate. So I'm gonna expand this. The teacher's asking, is it possible for students to either participate in one of your research projects or somehow collect data, run trials, etc.? Is there a way that people can participate in either one of your research projects or in the study of geoarchaeology in general?
So I have had students in the past intern in the laboratory when I was running a laboratory. Right now, I don't have any excavations going on, so it's a lot more difficult to work with student schedules. High school students in my field areas, it is possible to have internships in that regard, but what we're really trying to do to incorporate students is we're developing a green box down in Lincoln County, actually. So we'll be looking at archaeology and geomorphology, and I think that's going to be targeting high school students. So looking at how water really affects the landscape and where archaeology is found and where it's not. And so that's one outreach opportunity. Collecting data is tough. It is illegal to collect artifacts from public lands. And so the thing I hate the most is when people bring me artifacts. And students are really good at that. The Boy Scouts used to have a badge that was the archaeology badge, and so that sort of promoted that kind of thing. And everybody's grandpa has a coffee tin full of arrowheads, right? So I think that the thing to convey is really how important it is, context is, to, as soon as you pick up an artifact, it loses all of its value in the history. We don't know where it came from. And therefore all of its context is lost. And that's where the vast majority of its meaning is derived. Otherwise, it's just a pretty little thing. So where it came from is really important. But yeah, it's always a struggle to try to incorporate students because of field schedules and school schedules and especially the younger students. So laboratory tours is always lots of opportunity for that. And there's lots of fun activities that have to do with geoarchaeology that I would be happy to discuss with any of you if you want to do that. Even from collecting dirt from their yard and putting it in a jar full of water and shaking it and seeing how it settles out to see the difference between sand, silt, and clay, and that. So there's some fun archaeology things to think about, or you can do fake excavations and arrange those in boxes around schools. And they do that a lot down in the Southwest. So
that's really cool. Do you want to comment on any resources that you will be sending out to teachers? I don't know if you put anything in the folder, but give them.
No, I actually haven't. If there's any specific request, but I, as soon as the green box is ready and next year.
Totally. Yeah. Great.
We'll be ready.
Watch this space.
But I can take a look at some of the societies I belong to and see. I know that the Smithsonian has a really good for teachers K through 12. National Geographic has a ton of archaeology related resources for K through 12 teachers. There's actually a lot out there. Discovery Channel, again, they have a lot of teacher resource bases based on a variety of archaeology related topics. So those are probably the best, especially the younger kids.
Yeah, awesome.
I can play in the mud with them for sure, but I don't know if I can teach them.
Yeah, that's great. Yeah, it's a special kind of expertise.
Yeah.
All right, AJ, do you want to come on and announce the raffle winners?
Yes, it's
In the
my
meantime, I'm going to put the survey link in. So while you guys are listening, be sure to open the survey.
great. Okay, our first one that was at random is for Kaylee Sprague from Borderwick Bray. Are you here?
Yes, I'm here.
Yay! There's one. The next one goes to Abigail Grazad from Richard Bryan Elementary School. Is she here?
I'm here.
Yay! The next one goes to Matthew Moore from Priest Elementary School. Are you here? Oh, I saw his face.
I am here. Thank you.
Awesome, thanks. The next one goes to Sonia Foster from Don and B. Snyder.
Yay, I'm here.
Yay, awesome. And let's see, 1, 2, 3, that was 4, right? The next one goes to Kay Carey. Kay, are you here? Oh, I see her. You're on mute. You can just wave. Awesome. Let's see, 1, 2, 3, 4, 5. That's our 5 for the day. So you 5, make sure to send me your address where you want us to ship the gift cards, because you have to sign for them because they have to go certified mail. So, and then Megan put the link for our final survey. We really appreciate your feedback because this was a grant-based training that we wanted to put together for you guys. So any feedback we have will really help with our final reporting. A big thanks to Teresa for sharing her insights as an archaeologist. It's very exciting. Anything else, Megan?
I want to thank everyone for your fabulous questions. I was super engaged this week, and you guys just kept the chemistry going between the teachers and the scientists. So thank you all so much. We really appreciate it.
Thanks to AJ and Megan too for arranging all of this. And I'm sure me and all the other scientists at DRI are always happy to answer any questions you have. You'd be surprised. We don't get a lot of requests for in-person visits, and we always are happy to share what we're passionate about.
Thank you guys very much.
You're welcome. And it's Friday, you guys, and we're going to end a few minutes early unless anyone else has questions. You can stay on. Make sure you grab that link in the chat box. We can go from there. Have a wonderful weekend, you guys. Stay safe. And if you do have feedback for us on other trainings you would like, please feel free to either email me or just share it in the eval. But any insight to what your needs are and how we can help meet them, that's what we do. We apply for grants and to try to give you the resources, the skills, the training, whatever it is to help support you as educators. So please utilize us that way. Tell us what you need and we'll do our best to get it.
First certificates will be coming, you said, like in a week or 2, right?
Yeah, probably a week or 2. And I know some people had questions. You're emailing me. As far as I know, I'll double check the Opal account. I know for sure for Washoe County that you need to upload it to Opal, but I'm hearing from teachers from other counties it may be different. But we will send you a certificate. Chelsea will actually, thanks Chelsea, by email that has your name on it with the hours, and you either turn it in or upload it to whomever you have to count those hours for. Okay? Any other questions, you guys?
Thank you.
All right. Thanks, everyone. Thanks, Teresa.
Thank you very much.
Have a great weekend.
Bye.
Thank you very
Bye.
much.